Hey, hi everyone. Welcome to my YouTube channel. My name is Sunny Savita and I'm back with another exciting and useful video, guys. From past few days, guys, I couldn't upload a video. I was busy with some other work and all, and during that, I didn't get much time to upload a video. And in between, basically, I was getting a lots of messages and all, and even I get a lots of comment as well. Sir, when you will start with that particular playlist, when you will continue, like when we will get the next video and all. So yes, I'm here with the next video, like from the same playlist. And first of all, let me give you the quick background. Okay, so whatever we have covered so far, whatever we have learned on my YouTube channel, because on my YouTube channel, I'm uploading each and everything with respect to the generative AI, and that too in a particular sequence. So, guys, if you will go and check with my previous video, which was related to the advanced retrieval, okay, which was related to the like retrieval technique, and the technique was the self query retrieval. So it was a part of the advanced RAG series, and here when I upload it, if I can show you, then you will find out. I have uploaded that particular video on 25th of June. So it's been around 35 days, 30 25 days. I haven't uploaded any video, but don't worry. Now I am back. And we are going to start from the same point actually where I left, okay, where I left like 35 days ago. So here guys, inside this particular video I was talking about this self query retrieval. Now a couple of more retrieval technique was remaining. Definitely I will try to complete it, and apart from that I have created some amazing solution for all of you. And yes, guys. So, what are solution basically? Definitely, I will give you the update regarding it. And one more thing, if you are new to my YouTube channel, let's say if you are visiting first time, and if you want to start your generative AI journey, in that case, you can follow this particular playlist, because in this playlist, everything I'm uploading in a sequence. Okay, what is the playlist name, guys? Tell me. The playlist name is Generative AI from Basic to Advanced. Everything you will get it inside this particular playlist along with a roadmap and all. So definitely you should start your journey with a generative AI if you haven't started so far. And one more thing, guys. So far, most of my video related to the RAG only, but generative AI is beyond the RAG, and that too I will cover very soon. And I will be uploading many more video related to the other topic as well. And I'm thinking to start one free course as well for all of you. The course name is going to be Generative AI Bootcamp, and it's going to be a live course on my YouTube channel. If you want that course from my end, definitely you can let me know. You can let me know in the comment section. Yes sir, we want it. Please start from here and there, and you can suggest me the topic as well, sir. I want this topic, that topic, and based on that basically I will prepare my curriculum. And that course basically is going to be around for the 3 months, okay, a minimum, bare minimum time basically which I'm calculating, but it could be more than that. And on a daily on a daily basis actually I will be taking one live session every night, okay, after 9 o'clock, so that everyone can watch it, whoever is going to office or whoever is busy with their work and all. So it's I'm going to design for everyone. Now without wasting a time, let's start with the video. So the today's topic is going to be, guys, child to parent retrieval. Here is the solution basically which I prepared. Most of the thing basically I didn't keep, but don't worry, I will be explaining the entire thing. What is the meaning of this child to parent retrieval and why we are using it? Now, apart from this one, guys, here let me show you the topic basically. So this was a topic with respect to the retrieval. So here I have completed till fifth point, that was the self query retrieval. Now it's time to understand about this parent document retrieval, or this is called small to big retrieval, or child to parent retrieval, anything you can say. Then in tomorrow's video, means in the next video, basically I'll be discussing about this sentence window search. and then auto merging retrieval, and couple of other technique like hide and all, which is a part of like of the llama index documentation. I'll be covering the further technique from the llama index documentation itself. Okay, and that too I have shown you in my very first video of this retrieval. If you don't know, you can go and check. You will get a basic overview of it. Now guys, here see, retrieval basically I was covering, but apart from this one, what I have seen, people want some random topic as well. So recently, Meta has launched this llama 3.1. Okay, and many people want to create a rack using this llama 3.1. They want to access it, but in starting, actually when they are starting with their solution and all, they don't get a proper guide. Okay, don't worry, I'll be coming up with those kind of solution. Okay, how you can access llama, uh this llama 3.1 using the olama, using the hugging face. Okay, how you can basically get it from the hugging face hub, right? And if you are not able to get it from there, then what all other solution we have, I will let you know. So I'm preparing those type of solution for all of you. And here guys, you will be surprised that I have created one more solution related to this rag with llama 3.1. That's a quite amazing solution. So right after this particular video, you will get this rag with llama 3.1 as well. And here guys, you won't believe that I'm running this olama inside where, inside the collab itself. And I will let you know how you can set up this olama inside the collab only, so that easily you can test the different model and no need to install or download it inside your local system, right? So I hope I have given you the enough amount of information. And now let's start with the solution, guys. So here inside the solution, guys, what is a like retrieval name? So the retrieval name is child to parent retrieval. So inside this child to parent retrieval, what we do actually, let me explain you each and everything. But before starting with this child to parent retrieval, we'll have to understand the basic rack flow. Okay. So if you are not aware about the basic rack flow, in that case, you will find out some difficulty. So I would suggest you please go and check with my previous videos. Now, here guys, I capped one basic rack flow. So what is a basic rack flow? Let me again revise this particular concept. So we have a data, and this data basically we are dividing into the multiple chunks, right? Why basically we are dividing? So that I can perform the embedding and all, and we can store inside the database. Now this particular stage is called data ingestion. Okay, so here is my data ingestion. This is the first stage. Then after the data ingestion, guys, what happened, the next stage is called the retrieval. There we retrieve the data. Okay, based on what? Based on the user query. So let's say if user going to ask any sort of a query, so instead of passing that query to the LLM directly, what we do, first we pass that query to the database, and we perform the semantic search or similarity search, right? And then we perform the similarity search based on the semantic meaning. And wherever this query is going to be matched, okay, with whatever document, we retrieve those documents, right? And here, after the retrieval, we pass it to the LLM. So after retrieving, guys, like what we do, so after retrieving, basically we rank the document. So which is the most, whatever is the most relevant document, we kept at the first place, and rest of the document we keep in a ascending, in a descending order, right? So at the first place we'll be having a more relevant document, and then the relevancy is going to be decreased, so that is called the rank result. Okay, and this retrieval operation is also called the ranking. Now here, after the ranking, guys, if you want to perform the re-ranking, yes, you can do it. It is up to you. If you want to do a more level of filtration, uh it is possible. And even I have created a video of the re-ranking as well. If you will go and check, definitely you will find out those video as well. Now then what we do, we pass this particular result, this rank result or re-rank result to the model. So this rank result, actually it is called the context. Okay, and here we are passing the query, we are asking the same query based on this given context, based on given this particular result. And here we are giving the prompt as well. Prompt is nothing, actually prompt is an instruction to my model that I can explain you right in a simple term. So let's say I'm giving the context, I'm giving the query, and I'm telling to my model, okay, you have to do it like this only. Okay, you are a happy assistant, you are an angry assistant, right? Or you are a sad assistant. So here we are giving a emotions, we are giving an instruction to my model, using this particular prompt. The prompt is nothing. Prompt is just like a to a specific instruction to what, to my model only, to my LLM. I hope this basic RAG is the basic RAG flow is clear to all of you. Now coming to this retrieval, guys. So whenever we are going to retrieve this data from the database, okay, actually, this stage is quite important. Why? Because whatever we are going to retrieve from here, those particular thing we are passing to my model, right? If we are going to retrieve a good thing, we are going to be pass a good context to my model. If we are going to retrieve a bad thing, we are going to pass a bad context to my model. So this stage is quite important, guys. And here basically I was working on a different retrieval section, retrieval part, and the Langchain and Llama index itself, you'll find out couple of solution, okay, which has been proposed by the community. So among all those solution, one solution is called child to parent retrieval. Now, what is exactly this child to parent retrieval? We'll try to understand this particular concept now. So here is an image of parent to child to parent retrieval. So first we'll have to understand this particular mechanism. Actually, what is happening whenever we are going to retrieve the document, okay, and how we are passing the context to my LLM model. So here, guys, see, let's say you have a data. What I can do, I can write over here. So let's say you have a data. This data actually, it is also called document. Okay. uh, like you might have data inside any sort of a document. It could be inside the PDF, it could be inside the Excel, okay, or CSV, TSV, Parquet, ORC, Avro, any kind of file, okay, whatever file format you have, or even you can extract this particular data from the web as well, okay, you can perform the web scraping and all. So after collecting a data, what you have to do, you have to divide into the chunks. Now why we divide into the chunks? Because of the context length of the model. Because like let's say I'm a human, if you are telling to me everything in a single shot, hardly I'll be able to get something, and hardly I will be able to reply to you anything based on the based on like uh, the context, right? So the same thing happened with the LLM as well. If you are passing anything to the LLM, so it should be like under the context length, and different model actually it is having their own context length. So in some other video, I will discuss about the context length and all, because it's a separate topic. Okay, what should be the what is the length of the GPT, Gemini, or other open source model like Llama, okay, Mistral, or Cloud, right? Different models we have, different LLM model. So we have a data, and we data basically we are going to split into the chunks. Okay, chunks. So let's say we have these chunks. Now what happened, guys? Let's say this is my chunks, and now I create the embedding. Okay, embedding is nothing. Actually, it's a numerical representation or vector representation of the data. If you will go and check with our previous video, you will get a clear cut understanding related to the embedding and all. Now embedding, guys, so this embedding we always store where? Inside the databases, okay, inside the vector databases. We have a different kind of vector database. If you want to know more about it, you can visit to this particular video, sorry, not video, to this particular link. I will give you inside the description. So here you will find out almost all the data type, and here they have given you the factor based on which particular factor they are going to select the database, okay. So here you will find Apache Cassandra, MongoDB, Chroma, Pinecone, Files, right? Different database and the property related to those particular database, whether we can use it for the different category, different kind of filtration, hybrid search, different type of modality, okay, whether it's a open source or it is having a community support or not. Everything basically they have defined over here, so that you will get a clear cut understanding with respect to the vector database, right? Now coming to the next point here. So here, guys, you can see what we were doing. We were storing inside the database. Now whenever we pass the query, so here let's say we have a query. So this query actually it always interact with the database, okay, and based on this particular query we get the similar result, and that particular stage is called the retrieval, okay, as I told you, as I explained you inside this particular architect. Now guys, see here, whenever we are going to be interact with a database, let's say here is my query and here is my database. Now there is a specific size of the chunk. Okay, there is a specific size of the chunk. So means a specific size of the vector basically. A specific size of the chunk over here. Let me show you this one. This one. Okay, and a specific size of the vector, and it is nothing, it's a embedding basically. So here guys, see what happened. So whenever we have a large chunk, huge chunk, okay, and with respect to that, if we are going to make an embedding, and then we are going to perform the similarity search with respect to the huge chunk, okay, with respect to the huge chunk, the bigger chunk, in that case this process is going to be a quite slow, right? The similarity search and all. Why? Because see, there is two aspect. First is what? First is this interaction between this query and this database, right? And second is what? Second, we are passing the collected result to the LLM model, and that one is called the context. Here, this one, this particular one. Here you can see now we are getting this rank result, and then we are passing to the LLM. There is two things. So guys, this context actually it should be a larger one, okay, larger one. But this chunk actually like which we are going to create, or like we are going to create an embedding and all, and then we are going to perform the similarity search, it should not be a larger one. So there's a contradictory thing, right? So like here we have to find out that particular approach where we can interact with the database in a fastest manner, we can retrieve the like good result, and we can pass the like a huge amount of or we can pass the larger context, okay, the like as much as information to my LLM. Okay, there's two things. So we can solve this particular thing using what? Using this uh parent to child to parent retriever, right? So child to parent retriever, using this child to parent retriever, we can solve this particular thing. Now how? Let me tell you. So here guys, let's say this is a chunk, we are going to create an embedding, and here is what? Here is my database, and then this is what? This is my query. Now what we are going to do? We are going to make an interaction between this database, okay, between this database and this query, and we are going to find out a similar result, okay, similar result. Now guys, if this chunk is a small one, in that case this process is going to be a faster. But guys, just think over here, if we are going to pass, let's say we are getting a similar result, and this chunk is a small one, right? If this chunk is a small one, and if we are passing this particular context, this particular detail to my LLM, in that case my LLM is not going to perform well, okay, it is because it is not having a sufficient information. So here, what should happen? See, here, this chunk actually, it should be a small one. Let me write over here again. This chunk should be a small one. Okay. And this one, this thing, basically to the LLM, actually, we have to pass the bigger chunk. Okay. We have to pass the larger one, okay, large data, okay, huge chunk, okay, huge data, so that my LLM can understand everything in a easiest way, right? It can get the best to best context from the data, okay, whatever data we are passing for generating the final response. I hope this thing is clear. Now guys, here see what we are doing. So we have a data, original data, we are going to split the chunk. Now this chunk actually, it's got the parent chunk here, this one. So let's say here my data size around in my data basically I have, yeah, like this data actually is nothing, it's a PDF basically. So what we are doing, we are going to create a chunk. Let's say the chunk size is around I can write over here 1,000 tokens in one single chunk. In one single parent chunk we have 1,000 token, okay. Now what we are doing, we are going to create a child chunk, okay, here. So let's say inside this child chunk, how many tokens we have? Let's say inside this chunk we have a 5,000, inside this one also 5,000, 5,000, 5,000. Now whenever my query will come, okay, and it will be for the entire chunk. Now whenever my query will come, okay, so this query basically, this query is going to be interact with what? This query actually is going to be interact with this tell me guys, this query is going to be interact with this smaller chunk. And based on this smaller chunk, let's say my query is going to be interact with this particular chunk, okay, here is what? Here is my query. Now this particular query is going to interact with this let's say this is the relevant result, okay, this one, this particular chunk is a relevant chunk. So instead of returning this chunk, okay, instead of returning this particular chunk, this smaller chunk, I will return this huge chunk, bigger chunk. So that, see here, actually we are going to be find out a similarity search, okay, similarity search. Now we are going to find out a similarity search between what? Between the query and this chunk. So this process is going to be fast, means the multiplication and all. And then here, after the relevancy, okay, after finding out the the maximum relevancy, so we are not going to pass this same chunk to my LLM model. Instead of that, what we are doing, instead of that, we are going to pass this huge chunk to my model, so that my model, my LLM will get a larger context. My model will get a huge data, okay, so that it can understand the information in a quite easiest way, in a particular way. I hope you are getting my point, what I'm trying to say. So this problem is going, this solution actually is going to solve two problems. First, we are going to be retrieve the result fast, okay, and the second is what? Second, basically, we are providing a larger context to my LLM model. I hope this thing is clear to all of you. So here I have written the same thing, a smaller child chunk referring to the bigger parent chunk. So we are going to fetch the smaller chunk during the retrieval first, and then reference to the parent ID and returning the bigger chunk. Okay. Now let's look into the solution, that what we have inside the solution, guys. Now inside the solution, guys, I kept the same image so that you can refer it over here as well. And along with this particular image, I kept some theoretical point as well. So please try to go through with it, and it is trying to explain you the same thing which I have explained you just now over my blackboard. And I hope you got the clear cut idea, basically, like according to my explanation and all. So let's start with the implementation. So everything we are going to do using the Langchain itself. And here first what I can do, I can install the Langchain. So pip install Langchain. Now guys, see, we can do it using the like uh, we can do it using the raw Python as well, but the code is going to be little heavy. Okay, if we have a like a libraries like Langchain and Llama Index, so definitely we should use it. But you should be ready. Okay, let's say if you, in your organization, they are not going to use Llama Index or Langchain. Okay, they are not believing on it, or they are not trusting on like any third party APIs and all. In that case, you should be ready with your own logic as well. Easily you can do it if you have a basic knowledge of the Python. So here I am writing Langchain, Langchain. Okay, people install Langchain. Now, apart from the Langchain, we required some other library as well. So, over the Langchain itself, okay, inside the Langchain itself, you'll find out a couple of other library. Means inside the Langchain GitHub only. So here, the next one is the Langchain community. Okay, few separate code you will find out over here inside the Langchain community. Now we have one more. So here I can like give you this sentence transformer. It's a very important library just to like load a different embedding model and all. And I will give you like little more information, a little in-depth information related to the embedding, because I know many people are having some confusion. So, and don't worry, I'll be creating few other videos as well with respect to the embedding, that how the embedding is going to be generated using the transformer based model, the complete mathematical intuition regarding each and every stack of the transformer. So soon I'll be coming up with that particular video as well. So here is my language sentence transformer. Now apart from the sentence transformer, we have like couple of other things. So what I'm going to do here, so here guys, step by step I can explain the part. So first is going to be a data ingestion. We have to ingest the data, and this data basically I'm just going to keep some basic data only as of now, but you can take any sort of a data. Okay, and guys, see, if I'm showing you one example using any other data, right, means any basic data or any dummy data, so don't mention the same thing inside the resume. On top of it, what you can do, you can take some advanced data, you can take your organizational data. Okay, you can take your any real time project basically, and on top of it actually you have to solve it, because every time I don't have the real time scenario, real time project, but most of the time, basically 99% time I'm trying to giving you. But it's a request to all of you, please try to take a data, okay, the real original heavy data, and try to perform the same thing over there as well, right? I hope you getting my point, and you will follow it as well. Okay, that is what I believe. Now, what I'm doing here, I'm just going to be here is my data which I kept inside the which I kept inside my folder. So from the generative AI, actually, I'm going to load it. Just a second. So I'm going to load two files. One is this Paul Graham essay, and the second is the State of the Union. So here I've loaded two files, and now what I can do, I can keep it inside one folder. I'm creating one folder. My folder name is going to be a data. Just a second, let me write over here. My folder name is data. Now inside this particular folder, I'm going to keep this both file. So here is my state of the union, and the second is polygram. Don't worry, I will like give you the glimpse of the data if you don't know about anything. Now what I have to do, I have to load it. So it's a txt file. So simply I have to load the text loader from the Langchain itself. Let me close it. So here guys, I am going to import. Then I'm going to load the data, right? So what's going to be a process of loading the data? See, here is a path of the data, right? I already kept the code inside the notepad, so I'm taking a reference from there. But don't worry, I will give you this particular notebook so that you can run inside your system as well. So here's my file, okay, paulgram.txt. If you want to get a path of it, so simply click on this data, do the right click and copy the path from here. That's it. Now here we have another file. The file name is state of the union. Okay, in a similar way you can collect it. So we are passing this particular path to where? To the text loader. Okay, here is my text loader, and we are keeping inside the list so that later on I can iterate on top of it. So here guys, I'm going to iterate and loading the data. Where I'm going to load it guys? So I'm going to load this particular data inside this list. Okay, so here I'm going to iterate on each and every file, on each and every text loader, and finally after iterating it, finally after loading the data, okay, finally after iterating on top of it, I'm going to add inside where? Inside the doc. So like list is having a different function, append, extend and all. I'm using the extend method over here. Now what I'm doing, see, so after loading the data guys, if I'm going to execute it, let's say whatever like we are able to load it or not. So yes, definitely we are able to load it guys. It is saying docs is not defined. I can define it docs, and finally I have my data inside the docs. If you want to check, you can check it over here. So here is my data. Now what I will do guys, see, here this data I will be storing where? Inside the database. So I required my database as well. So for the database, I'm going to take Chroma. Okay, I'm going to use in-memory Chroma DB database. I can use Fize, Chroma, Pinecone, anything. I'm not going to use the cloud variant here. I'm going to store inside the memory only. So pip install Langchain Chroma. Here is my installation. Okay, what I can do, I can keep the installation at the same place. So whenever you are going to refer this particular notebook, you can install all the library all together. So here is my Chroma guys, and now let me initialize the database as well. So for initializing the database, just a second, after installing it, what I can do. So here I can create it. Okay. So first I'm going to import this two thing. So in memory store, and then second is the Chroma itself. Now what I will do then, basically I'm going to create my like collection where actually I will be storing my data, and then finally I am going to store it. Okay, so let me store it. Now where I will be storing guys, I will be storing in memory, and this is my final. Okay, this is my final storage, means it's my final retrieval. And after this one guys, what I will do, so here uh I have added my data. That's it. Okay, so this is the complete process, right? Which I am following over here, and step by step I'll be guiding you related to it. So basically what I'm doing now, one more thing guys, here you will find out this embedding, okay, and this child splitter. So we have to keep this two thing as well before passing the data to the database. If you don't know about the basic rec flow, in that case you should check with my previous video, then only you will get it. You can refer my this architecture as well. So here first we are doing chunking, and then embedding, and then storing. So we have a data over here, right? We have a database. Now chunking and this embedding is required. So we'll have to load the embedding model. First we'll have to do the chunking, and then we'll have to load the embedding model. So here guys, you can see this is my chunking, okay, recursive character test splitter. And here basically it's my child splitter. Again I'm saying child splitter. And what's the token size? The token size is 400, means inside the single sentence there will be around 400 tokens, right? Now what I'm doing here, so after this text splitter, okay, where actually I'm going to divide the data inside the chunks. Now what I will do, so here basically I require the embedding model as well. So embedding model wise, I can use any sort of embedding. So here guys, I kept this hugging face embedding for all of you. If you want to use this particular embedding, you can do. Otherwise, here what I can do, I can load the Gemini model as well. Okay, so for this particular solution, as a LLM, as a embedding model, I'm going to use Gemini, Google Gemini. But in my next one, in my next solution, which will be a continue part of this particular solution only, right? I'll be using the Meta Llama 3.1, and we will be creating the complete rank. We'll be creating the complete rank, and it's my promise to all of you. Now, here, what I'm doing, I'm going to take the Gemini as well, Gemini model. Let me copy and paste the code with respect to the Gemini, and here I'll be loading. So just give me a second. Loading what? Loading the Gemini model, guys. So here I have my both model now. If you want to use the Hugging model from the Hugging Face, okay, this all MPNet base 2, base version 2, you can use this also. If you want to use a Gemini, you can use a Gemini. So here inside this particular solution, I'm going to take this Gemini model itself, 1.5 Pro, because it is free and easily you can get the API key from the Google AI Studio. Once you will search Google AI Studio API key, so you will get this particular page, and then you can generate the API key. Okay, just click on this get API key and then generate it. So from here itself, I have generated my API key. So what I'm doing, so here you can see guys, I given you a couple of more information with respect to this embedding. I will take one separate class related to this embedding, but how to decide this embedding? So you can decide it based on the data size. Okay, so here computational resources, task complexity, embedding dimension, okay, performance versus efficiency trade, right? And here the last one is the experimental. So it's an experimental key as well. So here you can follow this particular point whenever you are going to select the embedding base model. Here I given you some link as well. So one very famous model, quite like a famous model from the BGE. Okay, BGE, basically the full form is BAAI Journal Embedding. So it's a like a Beijing based company. Okay, it's a Chinese company which have trained a lots of model, lots of things. Definitely, you can go through with it, and you can understand about the embedding and all in a detailed way. And you can check what all module basically they have. Now we have one more sentence transformer. You can visit this also. Apart from this one, you can check the Hugging Face leaderboard, and you can look into the MTEB. What is a MTEB, guys? It's a massive text embedding benchmark. So based on which benchmark and all, they are going to be select the embedding model. Okay, everything basically you will find out over here. I'll be taking one separate session, but yes, I given you this particular resources over here. If I'm going to explain you everything inside this particular video, so it's going to be a quite long. So that's why I'll be discussing that in my next video, where I will show you how you have to decide the embedding model. Now here is my Hugging Face one. So I'm going to comment it down. As of now, I'm not going to select this one. Instead of this one, I'm going to select this Google embedding, right? Gemini embedding basically. So yes, I have a model. I given the access of the key because I saved my key over here. You can also create and add new secret, and you can create this Google Gemini API key. You can keep the value, means this API key, whatever you will get it from here, and then just give the access. Okay. So yes, we are able to load the Gemini model, embedding model. Now what I have to do here, just a second. Okay, so this code, guys, you will find out below this embedding model. Basically, I have to keep it over here. No issue. What I can do, just a second, I can cut it from here, and let me keep it after this one. So here is the code for the embedding. Got it, guys? So this is my embedding model, and this is going to my Gemini embedding. So let me keep over here the Gemini embedding. Now here, this is going to be a collection name. Means I'll be keeping my full document, okay, complete document, and with respect to those particular document, I'm going to create a child, child chunks, okay. So here is a size of the child chunk, child splitter. So what I'm doing, so this is my in-memory database, and here this is my class. This class actually will find out inside the Langchain itself, parent document retriever. Now inside this parent document retriever, you are passing the vector store, okay, where actually you are going to store the data. Then here you are going to store in memory, and here is a child splitter. So this parent document retriever, what it will do, so whenever you are going to ask anything to this parent document retrieval, okay, whenever you are going to ask any sort of a thing to this parent document retriever, to this particular retrieval, so based on the child similarity, it will return the parent document. Okay, how? Let me show you. So here, guys, first of all, let me execute it. So this is my vector store, and here it is saying chroma is not defined. Let me define the chroma. So this is my vector store, guys. Here is my in memory, and then this is my retriever. Now inside the retriever, basically what I'm doing, I'm going to add this document. Okay, means my data. So child splitter is not defined. Now I think it is defined. So here is my child splitter, and then we are going to add the document over here. Now let me keep this information as well above one only. Just a second. Yes, so here I kept this particular information over here, and let me keep the Hugging Face code as well. So I'm just going to copy it and let me paste it over here. So this is going to my Hugging Face code. I hope everything is clear, guys. Now maybe you are getting confused, but now everything is going to be clear. See, so we have added the document, means the full document. We haven't we haven't divided the data in means the entire document. Actually, we haven't divided into the parent document. Okay, so here what we did, we have added the document, and here is what, here is my child splitter. Okay, means we have a complete document. How many document? Two document. How many document we are going to store? Two document, right? This one. And with respect to this document, we have a child chunk. Okay, now whenever we are going to query, whenever we are going to perform the similarity search, so based on that particular similarity search, it will return which document? Tell me. Parent document. Okay, so let's see whether it's going to return or not. If you want to check the parent document, guys, you can check out over here. So just like call this store yield key, and here you will get the list of it. So we have two document. It's a key, basically. It's a first key related to the first document, the second key related to the second document. Now what I'm doing, so here, guys, I'm going to be call. So let me take this retriever, and this retriever actually it is having a different method. So here you can see like one method, the method name is invoke method. I'm going to call this invoke method. Let me write over here invoke, and I can write any sort of a word sentence, and according to that it will perform the similarity search. Okay, so this is it's a suggested question. I can take this particular question, and if you don't know about the data, let me show you the data, basically how it looks like and what we have inside. Just allow me a minute only. uh so generative AI inside this one data set, and guys, this is my data. So Paul Graham essay, and this is the essay basically about the Paul Graham. So just a second. Oh, where it is, this one. So here is my complete data. So you can see the complete essay, okay, what I worked on, and before college and all. Basically, he has written the complete story about himself, and like yes, based on this particular story, I can ask any sort of a question. If you want to know more about this particular data, you can simply search Paul Graham essay over the Google itself. Paul Graham essays. Okay. So here, is there such a thing good at like how to do the great work, how to make a bell, how to work hard, everything basically they have combined over here. What are the best program essays? So these are the couple of essay basically which you will find out top 10 essay based on their references and authority. So you can check out, and this is one of them basically. Similar to that, we have one more data. So inside that data, you will find out what? You'll find out the speech of the US president, okay, State of the Union. You can search about that as well. So now what we have. So here, guys, if we are going to invoke it, so this is the like question basically. It is from the speech State of the Union. So if we are going to be invoke it, so here what I will get, I'll be getting the answer. Now, guys, just look over here what I'm getting. So if you will look over here, so it is giving to me a parent document. Okay, it is giving me a parent document. This one, parent document. But just look over here. This parent document is a complete document. It's a complete data. So this data actually, it should be a parent chunk now. Parent chunk. See, here, what is happening? Let me explain you. So let's say we have a document. So this is my document. Just a second. So what we have? We have a document. How many document? Two document. Okay. So we are going to create a chunk using this two document, and this chunk actually it's going to be a child chunk. Child. Now my query is coming. This query it's going to be interact with this child chunk. Okay, and based on the similarity, right? See, this here is a two document. Let's say this is asking a query about the Ketan G, and here it's going to be find out a similarity search, right? Let's say this is my document, and this document is coming from where? Let's say here is my first document, state of the union, and here is my second document. What is the name of it? Tell me. Essay. Okay, Paul Graham essay. So tell me, this chunk actually it is belonging to this state of the union or this essay? It is belonging to this state of the union. You can check out, right? So what it is returning, what it is returning? It is returning this complete document. It is returning this complete document, parent document, and this particular document we can pass to the model. But guys, just think over here. This document is not a quite huge. Okay, this document is not a quite huge. It is it, guys? So if you will look into the number of tokens over here, so you will find out. Just a second, let me show you. So what you can do, you can just like a print this thing. So here I can keep it, and this thing actually, this response, I can keep it inside the retrieve docs. Okay, this one. Let me execute it and see the length of it now. So here I can show you the length also. Literally, you will be surprised that the length is going to be little huge. And what I have to get. So I don't want this much of data, 38,540 character, and the token basically you can calculate the token as well. But the token will be around maybe 10,000, 20,000 somewhere. So here, what I want to do, I want to get a parent chunk, not a complete document. Parent chunk, not a complete document. So how I can do it? Let me show you that particular part. So here, for that basically, let's say this was my child splitter. This was my child splitter. Let's say the child splitter size is 500 tokens, and here I have my parent splitter. So parent splitter size, now this time I am keeping 2000 token, not the complete document. And now again I will be creating my vector store here. So how basically we are going to store the data? We are going to store inside the we are going to store in memory itself. So this is my parent document retriever, and this is my second object retriever 2 I can keep. And we are going to store where? Inside the memory. So let me define the object one more time. So it's going to be create a fresh object here. So store one, I can say it's store one, and I can keep it over here. This one is store one. Understood, guys? Tell me yes or no. I think yes. So we have a child splitter, we have this parent splitter, we have this store one, and we have this vector store. Vector store basically the previous one. I can keep the new as well. So let me create the new only vector store one, because there in the first one it was returning the complete document. So here what I have, let me show you that. So here is my vector store one, this one, vector store one. Okay, and see now along with the child splitter we are going to pass the parent splitter also. Getting my point? So based on the just look over here inside this particular like a basically blackboard. So we are passing a query. Here it is going to be interact with the child document for the fast retrieval, for the fast multiplication and all with respect to the embedding. Then instead of giving this entire document, it is going to return what? It is going to return the parent document. So wherever, in whatever parent document I have this similar thing. Okay, let's say this particular thing, this child chunk, it is belong to the it is belong to this particular document, parent document, where we have 2000 tokens. Okay, so it will return to this one now. I hope you are getting my point. So now let's do one thing. Let's try to execute it one more time. Here is my child splitter, here's my parent splitter, here's my story one, here's my vector store one, and here is what? Here is my retriever 2. Now what I can do, I can add my data inside this retriever 2 one more time, and this time guys I'll be finding out we don't have two document. Okay, we'll be having more than that. So if I'm going to check the keys now, so in total I'll be getting how many keys? Let's see over here. So with respect to my data, store list of store, okay, store one. So it is my store one. So here guys, you can see we have 66 keys. Means it is not a two document, it is 66 parent chunk. It is 66 parent chunk. Okay, now here what I can do, I can check with respect to the first one. So here inside the first one, basically we just have two document. Now I can check out. So what I can do, I can invoke the same question. Okay, so let me invoke the same question over here, and this time guys, let's see what is going to be my answer. So here guys, if you want to check, this is my retriever 2, and here we are going to invoke it, and this is my relevant document 2. Let me execute, and then you will find out the length of it. So here guys, just a second, let me show you the length of it. So here the length is going to be around your document 2. uh and just see over here, this is the page content. Okay, first of all, see here the length is 1849. Before, basically, it was giving the complete document. Now it is giving me a parent chunk with respect to this question. Now let me show you how many chunk basically is going to return. So if you are going to see with this retrieve document 2, okay, so it's going to return two chunk by default, two parent chunk. Okay, so inside this one, now inside this particular method, so inside this invoke, basically it is having a different like a parameter. You can pass a value of k. So by default it is going to return two. It is going to return two parent chunk. Okay, this one, I hope you are getting my point. This is the parent chunk. If you want to check the a child chunk, okay, with respect to this particular question, instead of this invoke, you can run a similarity search. Okay, this retriever 2 means this retriever object, it is having one more method. Let me show you the method name. What is the method name? So once you will call query, sorry, similarity search on top of it. Here is what, here is a method. Mm, schema search category search type, schema transform validation with and vector store validate, stream search type. And here guys, there was one method. Let me check out what was the method name. Okay, not this one guys, actually not on top of the retriever. You have to check it with the store. So just check out with the database store one dot. So you can check out with the similarity search. Let me show you whether we have a method or not. So yes, it is having a method similarity. Okay, this is the in memory. So this one is a correct one. And now I can check out similarity. Yes, guys. So it is having the similarity. So this will give you the child document as well. This particular method. Okay, on top of the database, actually you need to call. I hope it is getting clear. So let's try to pass this data to my this particular data, this parent document to my, tell me, model. So now I have to perform the data generation. So here I'm going to load my model. Here is my LLM guys. And now I'm going to create my chain as well. So this is my chain guys. And here, let me keep my chain. So see, my model is working fine. I'm able to load my model, and here is what guys, see, Langchain retrieval QA OpenAI, and here to the LLM, basically I'm passing this Gemini LLM. Okay, here is my chain type is stuff, and then here is what, here is my retriever. Now this retriever, actually it's going to be a retriever 2, which is going to be written to parent document. Okay, which is going to be written to parent document, where it is this one, to parent document. Now, if you want to check with the child document, again, I'm saying you can call to this particular method, similarity search. You will be getting, you can call with the same question. Now, let's ask the same question, okay, to which one? So, let's ask the same question to my model now. So, based on the context, basically, I will be getting my answer. So, here is my query. Now, I just need to run this particular chain, okay. So QA.run with this particular query, and let's see what I'll be getting over here. So yes, I will be getting my final answer. So let's wait. And this is going to my final answer, guys. Now, this is just a prototype basically, which I shown you, right? But here, we have to like evaluate our result, right? Whether it is correct or not. And whatever thing I'm saying, based like whenever it's going to be find out the similarity search, at that time it's going to be fast. But whenever we are going to pass those similarities those smaller document, the model is not having enough information, so that thing also we have to prove. So for that, actually, in evaluation technique is required, rag evaluations, right? As of now, in your solution, wherever you are going to perform, wherever you actually you are going to create a rag, you can try to check with this particular approach, child to parent retrieval. If it's going to work well, it is fine. If not going to work well, you can check with the other retrieval technique. Again, I'm saying every retrieval technique does not work, means with any solution. Okay, it's not like this that every technique is going to work. No, child to parent retrieval is going to work for some specific solution, some other technique is going to work with this with some other problem statement and all. So you need to check out, and it's all the experimental experimental thing and all. Okay, and but it's a proved one as well. That's why you will find out the solution and all inside the Langchain as well. Langchain and the Llama index. Now in the next video, I'll be showing you some other technique, and I'll be creating the RAG using the Llama 3.1 as well. So until guys, thank you, bye bye, take care. We'll meet you. I will see you in the next video. So keep watching, keep learning. If you have any doubt, you can let me know. You can reach out to me on my LinkedIn. There, definitely, I will helping you with your doubts and all. So thank you, bye bye, take care.